Hey guys, I hope everyone is doing well. So far we have gone through how to create a function graph that will take two inputs, that is data and call index. Call index being a list of column numbers that you want to plot. Now let's see how we can further improve this code. What if the user wants to save the images or graphs to a different directory? Now since both call index and directory are optional arguments, we use the keyword arguments. Keyword arguments allows keyword-based arguments. This function is expecting keyword arguments as call index and user-defined directory where plots need to be saved. It will plot histogram and box plot of all the numerical columns and bar plots of categorical columns and save them in current working directory if no directory is mentioned by the user. Otherwise, the plots will get saved in the directory passed in the argument by the user. Now, suppose the user enters a directory path with a folder name that doesn't exist. We will create the folder and save the plots in it. Now this can be done by using the function os.mkdir and passing the directory entered by the user to this function. This function will automatically create the folder by the folder name in this directory. Now what if some of your categorical data are actually numbers? For example, we have this cars data set. Now cylinders is actually categorical. Let's see this. We can see different numbers in cylinder. Now different values that cylinder can obtain is 3, 4, 5, 6 and 8. These are the number of cylinders. The mean calculated is 5.47, which does not have any meaning. 5.47 cannot be the number of cylinders. It can either be 5 or 6. And the data type is integer. Hence, it treats cylinder as numerical data. And hence, it does not plot a bar graph for this. Instead, it plots a box plot for this. Now how to solve this problem? If the number of unique values in a numerical column is less than 15, you can take any number. We have set as 15. Then treat the column as categorical data and hence plot the bar plot for the column. And if the number of categories in the categorical data are greater than 25% of the total data, it becomes very difficult to analyze the graph and hence we avoid to print the graph of the same. For example, in the cars dataset, the car column has more than 200 unique values and hence the plot does not make sense.